Functions and graphs review homework help video. Let's just jump right in with problem number 1. Find the distance between each pair of points. Leave your answer in a radical if needed. So when we have a graph like this, let's just turn it into a right triangle so we can use the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the shorter sides of this triangle. We can see that they're 2 units each, so this is 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. 8 equals c squared. Take the square root of both sides. And I'm just going to leave my answer like this. The square root of 8 is equal to c. That's what it means by leave your answer in a radical if needed. Now if I just get 2 ordered pairs, then maybe I'm going to use the formula. So first label these x1, y1, and x2, y2. And then use the formula distance is equal to the square root of y2 minus y1. I made that look like an exponent. That's actually a subscript. y2 minus y1 squared plus x2 minus x1 squared. Let's plug in what we got. Distance equals the square root of 8 minus a negative 6. There's a minus in the formula plus the number is negative, so that's why we get minus a negative squared plus 8 minus a negative 6. It's the exact same. Oh wait, I didn't write it the same. Squared. 8 minus negative 6 is the same as 8 plus 6, or 14. 14 squared is 196. So we've got distance equals the square root of 196 plus 196, which equals the square root plus 196 of 392. I'm going to double check that that's not a perfect square root. So square root 392, and I get a decimal, so I want to just leave it as this. All right, find the midpoint of a line segment. Slightly different formula for this. We want to do, again, label them the same way, x1, y1, x2, y2. But then the x value of our midpoint is equal to the average of the x values. And the y value of our midpoint, exact same. It's the average of the y values of the endpoints. So negative 5 plus a negative 5 divided by 2. That's going to be negative 10 over 2, which still is just negative 5. Halfway between negative 5 and negative 5 is still negative 5. Y1 plus y2 over 2 equals 1 over 2 equals 1/2. Put it together into an ordered pair, negative 5, comma 0.5. I don't mind a decimal here. I think that looks fine. All right, other direction. I've got the endpoint and a midpoint. Same formula, but fill in different points. So the endpoint is still a x1, comma y1. But the midpoint is just an x value of the midpoint, y value of the midpoint. Still plug them in. So x value of the midpoint is a negative 9 equals negative 1, or negative 5 plus unknown over 2, but we only have the one unknown, so we can solve here by multiplying both sides by 2. Negative 18 equals negative 5 plus x sub 2. Add 5, add 5. We get negative 13 equals the x value of our other endpoint. And that makes sense. Negative 9 is halfway between negative 5 and negative 13. All right, same thing for y. I do 0 plus the unknown y2 value divided by 2 equals the y value of my midpoint of 6. Multiply 2 to both sides. Y2 equals 12. Let's put it together into an ordered pair. Negative 13, comma 12. All right, state the x and y intercepts for each line and then use that information to graph the line. So let's do that with number 6. This looks a little bit more difficult. So first I'm going to set y equal to 0. When y is equal to 0, we find the x-intercepts because we're along this horizontal line at 0 here. So 0 equals x squared minus 9. Add the 9 to both sides. 9 equals x squared, square root. 3 equals x, but the square root of 9 is also negative 3 equals x. I need to include both of these, negative 3 and 3. Now let's plug in a 0, so what happens when x equals 0? Well, y equals 0 squared minus 9, y equals negative 9. That's this point down here. Connect them up into a parabola. All right, and we know it's a parabola because this is an x squared equation. Same thing over here, but you just get 2 points and then make a straight line. Slope of a line between 2 points, we can practice one of these. Again, we label it x1, y1, x2, y2. You notice we've done that for 3 different problems now. Now the formula for slope is slope equals y2 minus y1 over x2 minus x1. Which equals negative 2 minus a negative 20. We got a minus from the formula plus a negative from the negative 20 over 17 minus 19 equals, that's an 18, that's a negative 2, that's a negative 9. All right, moving on. Use the information provided, write the equation of each circle. So we need our general form of the equation of a circle, and that is x minus h squared plus y minus k squared equals r squared. And then the center of that circle tells you h comma k. And then the radius tells you r. So that radius, which just goes straight up, is the easiest way, is 3. So r equals 3, and h comma k is 3 comma negative 3. So we plug that into this formula here. We get x minus 3 squared plus y plus 3. So there's a negative there and a minus in the formula. That becomes a plus. Equals r squared, but we can do that in our head. 3 squared is 9. All right, very similar for number 10. You just label this h, k, and r, plug it in. But 11 is a little bit trickier because we just have a point on the circle. So we got to find our radius by doing that distance formula. So distance equals the square root of the change in x's squared, so that's just 1 squared or 1, plus the change in y's squared, so that's 2 squared or 4. So the distance there equals the square root of 5. That's our radius. But in the formula, so I'll just label that r. R gets squared, so this square root of 5 is going to become just a 5. So this becomes the equation x plus 3, we flip the sign on that 3, squared, plus y plus 15 squared equals just 5. All right, circumference equals 2 pi r. 10 pi equals 2 pi r. Divide both sides by 2 pi. The pi's cancel out, and 10 divided by 2 is 5, so 5 equals r. You can finish the rest of that one. Convert to general form. This is where we have to FOIL out the first expression and the last expression. So we need to do the x minus 4 squared as x minus 4 times x minus 4. That becomes an x squared minus 8x plus 16. And then we do that with the y's, and then we put it into the form ax squared plus by squared plus cx plus dy plus e equals 0. And that is general form. So FOIL both, combine all your like terms into that pattern. All right, fill in the missing variables so that we get this slope. Okay, we're going back to that slope formula. We'll just do 14 here. Let me clear a little space. A little too big there. Small. All right, the formula was slope equals y2 minus y1 over x2 minus x1. So just fill in what you've got. The y2 is a -4 minus the y1 is a 9 over the x2 is a -3, but the x1 is just an x, so we'll just leave that as an x, equals 13 over 2. Simplify this side here, becomes -13 over -3 minus x equals 13 over 2. Cross multiply isn't a bad idea here. So we get -26 equals 13 times -3 minus x. I'm not going to distribute that because I just want to divide that 13 away. -2 equals -3 minus x. Add 3. 1 equals -x divided by -1. X equals -1. For this one here, if we make that a -1, then we get that slope. All right, write the slope-intercept form of the equation of this line. Well, let's look at where it crosses the y-axis. That's -3. Let's look at the slope by doing a slope triangle. Down 1 over 1. That's the slope of -1. So y equals -x minus 3. Then graph a line that's parallel. Well, the only thing that matters is that I keep that same slope of -1. And then I can make its y-intercept wherever I want. I can put it up at 4, keep the slope of -1, and this is going to look like 2 parallel lines. All right, for a perpendicular line, all right, we cross the y-axis at -2, and we've got a slope. Let's see, make a slope triangle right here of down 2 over 3, so -2 over 3. So this line here is y equals -2 over 3x minus 2. For the perpendicular slope, you take that -2 over 3, you flip it upside down, and you make it opposite, so it's just a positive 3 over 2. So y equals 3 over 2x, and then we can do whatever we want for the y-intercept, including 0. I'll just leave it like that. Up 3 over 2, down 3 backwards 2, and these two lines should intersect at a 45-degree angle. All right, draw examples of each type of symmetry. X-axis just means it's flipped over the x-axis here. Y-axis, we could do something like a V shape that's symmetrical over that y-axis, or you could draw 2 stars. Symmetrical over y equals x. This one's a little bit trickier. If I've got a graph that does something like this, I can take each point, like this point here, which is at 6, 4, and flip it, make it 4, 6, to get my symmetrical point. All right, let's actually talk about all of these. For x-axis, the point x, y becomes the point x, -y. Here, the point x, y becomes the point -x, y. Here, the point x, y becomes the point y, x. And we get something like that. And then origin, the point x, y becomes the point -x, y. We flip both sides. And for this one, something like an upright star over here becomes an upside down star over here. So let's try to do our best. So I kind of came from here over, stop right there. All right, that's origin symmetry. Rotate 180 degrees around the origin. All right, an example of a constant in a cubic graph. Constant has to be horizontal. Cubic can make an S shape with 2 turns, opposite end behaviors. Linear, straight line across the graph. Quadratic is U-shaped. Logarithmic goes all the way down to -infinity and then curves off like this. So it doesn't stop. This arrow keeps going down to -infinity, but it becomes almost vertical, and there's nothing over here. Rational, you start by dotting in a horizontal line and a vertical line, and then you fill into 2 of the corners with curves like this. So fill into corner 1 and corner 3. That's a rational graph. Square root kind of like logarithmic, but it just stops at one point and then it curves off. Absolute value V-shaped. So we'll switch the colors. This is two different graphs. Absolute value V-shaped. It's two straight lines with a very pointy center, unlike quadratic, which is U-shaped. It's curved the whole way through. Okay, we'll do this one, and then I'll pause the video. Construct a scatter plot. State if there appears to be positive correlation, negative correlation, or no correlation. When there is correlation, identify the relationship is linear or nonlinear. Also find the slope-intercept form of the equation that best fits the line. All right, so how do we plot? 0.11, we go over to 0.11, up to 0.19, about there, 0.21, 0.28, 0.36, 0.39, 0.6, up to 0.57, 0.62, so just past that. Very close by point. Should actually be a little lower than that point, but that's okay. 0.76, 0.65. Okay, so this looks like positive. It looks linear. It looks like a strong correlation, but we don't actually have to say that. And now I need the slope-intercept form of this line. So you do your best to put a line through here that gets as close to all the points as possible. And then we can pick 2 points to do a slope formula with. And they don't have to be part of our data set. So I picked the point 0.1, comma 0.2. Actually, to save yourself some time, do your best to pick a point that's right on the y-axis, and then we can just use that as our y-intercept too. So I'm going to go with 0, comma 0.1 and 0.9, comma 0.75. All right, slope formula would be 0.75 minus 0.1 over 0.9 minus 0 equals, let's see, it's 0.65 over 0.9, 0.722 for our slope. But because we picked this point, we can use that as our y-intercept and get the equation y equals 0.72x plus 0.1. All right, I'll pause it here. Start it up again in the next video.